All right, IGCSE student. We're now going through this question again. Once you see number of moles and stuff being asked, then you know you're doing chapter 3 stoichiometry, and we're going to apply the principles we've just been learning. So, now, what we know is that we have 3 formulas. I love this question because it's going to show you what I've been talking about. Number of moles is mass over molar mass. So it could be AR, it could be MR. So you can just say mass over molar mass. So you put AR or MR depending on what the question is asked you. Number of moles is concentration times volume. Number of moles at RTP. Number of moles is equal to the volume that you have gotten, but make sure it is in dm cubed divided by 24 dm cubed. And how do you put volume in dm cubed from cm cubed? You just divide by 1,000. So that's an easy one. You just divide it by 1,000. Anyway, these are the 3 formulas. Now, what do we know? We know that the first time they ask us for moles, sometimes they will ask us for mass, whatever. We don't use the formulas. But the very first time they ask us for moles, we choose one formula on the 3. The next time they ask us for moles, we use ratios. The third time they ask us for moles, we going to use, they don't ask us for moles in the third situation. They'll ask us for volume or concentration or whatever they ask us, or mass or whatever. You come back to the formulas. So we use the formulas in the first step and in the third calculation. Easy. I've given you the method and you're done. So you put the 3 formulas, you know you're going to choose one. So look what they're asking for. Number of moles of HCl. Okay. So they want number of moles of HCl. Where? What have they given us? If they've given us mass or whatever, in 50 cubic centimeters, this is volume. Of 0.1 moles per dm cube, this is concentration. So obviously, you are using this one. Number of moles is concentration times volume. So you put number of moles is concentration times volume, which is, what is the concentration? 0.100 moles per dm cubed. So it's easy to choose the formula. Look at what you've been given. Then you multiply by the volume. Now we know that the volume should be in dm cubed. And we know that they will never give us in dm cubed. They'll give us in cm cubed to try and trap us. But what we know is we will divide it by 1,000 to change it to dm cubed. So you say 50.0 divided by 1,000, so that it is now in dm cubed. It should always be in dm cubed. So the number of moles will be 0.100 moles per dm cubed times 50 divided by 1,000. So it's like 5 over 100, 0.05 moles per, no, it's not moles now. It's just dm cubed. So now 0.1 times 0.05. It becomes 0.005 moles. There we go, 0.005. Now we go to the second step. We cannot use the formulas. We use the ratios, and we must be good. This is where we must be good, because everybody knows, yes, we use ratios, but the question becomes, how? Do you actually know how to use the ratios? So if you're not good at ratios, listen. Here's how you do it. Now they'll ask you for moles of CO2. So first, go to the equation and see the ratios. Okay? Go to the equation and see the ratios. Let's go to the equation. What ratios are there? Well, we got moles of what? Of HCl. Now we want moles of what? Of CO2. So let's check. HCl versus CO2. Here is your HCl. Here is your CO2. So you can now say, if you want, come here to say HCl S to CO2 is 2 for HCl and 1 for CO2. So it's 2S to 1. Because HCl had a 2, CO2 had a 1. We don't care where it is. We just look for them. We have found them. So these are the ratios we are using. Because we have HCl, we are looking for CO2. So those are the 2 we are working with. The one we have and the one we're looking for. So now what we're going to say, we will now say, because we are good at ratios, we'll now say number of moles of CO2. The one you're looking for will be, you start with the number of moles of HCl because you just got them, 0.005. So 0.005 moles. Then what do you do? Okay, because that's the one you have. What do? You now go to the ratio. You've gone to the ratio. What do you do at the ratio? Divide by what you have, multiply by what you are looking for. You divide by what you have, so you remove what you have. Then you multiply by what you're looking for. So let's remove what we have. We have 2. We have HCl, so that's the 2. We divide. We multiply by what we're looking for. We're looking for number of moles of CO2, which is the 1. So we multiply by 1. So you actually now get number of moles of CO2 being 0.0025 moles. So it's 0.0025. Now we go to so we've used ratios. Now we are at, the only reason I've kept it as one video, although it's now at 6 minutes, is because I wanted you to be able to do it all step by step, not in pieces where you at this, you're not good at the other one. So just do. Now here we have it. Calculate the volume in cubic centimeters of carbon dioxide produced at RTP. Now, it's not about the question. I'm not interested in the question. I never care. I don't want the question. I want you to know this is the third calculation. So, IGCSE student, use one of those 3 formulas. Be serious. So you go to the 3 formulas. Which one works with this at RTP? Which one? It's only this one. So it's not complicated. That's the only one. So write the formula down. So you're going to write number of moles is equal to volume in dm cubed divided by 24 dm cubed. Okay, this is at RTP. You show this. Show that you know. Now what they want is they actually want volume, but they don't want it in dm cubed. They want it in cm cubed. So I can show you the long way, or I can also show you that this same formula here, we can also write it as volume in cm cubed, okay, in cm cubed divided by 24,000 cm cubed. It changes, the formula changes, the same formula. But if it's now at RTP, if it's now in cm cubed, you divide by 24,000. That's the formula. So what we can now do, they want volume in cm cubed, so we take 24,000 to the other side. Number of moles times 24,000 cm cubed is equal to the volume in cm cubed. What is the number of moles? What is the number of moles? We're still dealing with CO2, so the number of moles of CO2, we just got it. So you can say now the volume of CO2 is actually, what is the number of moles? 0.0025 moles times 24,000 cm cubed. What do you get? Let's multiply. Let's get an answer. I'm going to multiply 0.0025. I multiply it by 24,000. I will get 60. So this is 60 cm cubed, which is realistic. So you know that you're probably correct because it's realistic. So there we go, 60 cm cubed. Anyway, this is the volume that we had, 60 milliliters or 60 cm cubed. We're done. So now I'm happy because what I made sure you are good at is following the procedure. You know how to use ratios. You know how to do the calculations. This video alone is enough for you to be able to now start to try your own questions in the worksheet on your own. So now I believe you can actually do it. Okay. Now I want you to try out the rest of the questions, and let's see how you do. You use the same procedure, and you're going to be fine.